Hi, we're looking at a radical expression. A radical expression is going to let you know what action you're trying to perform, a square root or cube root. And all of that's indicated by the index. So this right here is the index. And unless it's given to you, you're going to automatically assume that it's going to be a square root. Now you're taking the root of the radicand, and that's the number underneath the square root symbol. Usually this can be done with a calculator. And then lastly, in a couple of these questions, we're going to be talking about a coefficient, which is going to exist outside the radical. And that's going to be a number that has been simplified. Section R7, we want to remember PEMDAS. So the first thing we want to do is learn how to simplify one of these radicals. So what you do is you're going to split up the radical, and you're looking for the largest perfect square. And then you're going to simplify what you can take the radical or the square root of, which in this case it's only the 49. And then because you can't take the square root of 3, we're just going to leave it underneath the symbol. So then when you take the square root of 9, you get 7, and then you just bring down the 3. So it's 7 times the square root of 3. So when you're looking at something like a number 1, you're saying the square root of 7 squared equals 7. You can do this on a calculator as well. So number 2, it's like negative 1 is being multiplied by the square root of 289. If I take the square root of 289, I'm going to get 17. And then my final response is going to be negative 17. So you want to go ahead and box your solutions. For number 3, it does look a little bit more difficult, but it's pretty simple. What we do with number 3 is we're going to take the square root of the numerator and then take the square root of the denominator. Our solution will still be a fraction. So the square root of 100 is 10, and the square root of 49 is 7. This is our solution. Number 4, the square root is being multiplied by negative 1, so it's going to be a negative 1 times the square root of 225 over the square root of 4. That square root is for both the numerator and the denominator, so you have negative 1 times the square root of 25 is 225 is 15. The square root of 4 is 2. So it's going to be negative 15 over 2. Okay, so for number 5, we're taking the cube root. The cube root is indicated by the index. Remember, the index is the same thing as the power. So if you take the cube root of 125, it's like saying 5 to the third and then taking the cube root of that. The index and the powers are going to cancel, so you're left with whatever is underneath the radical, and the answer is 5. For number 6, it's the same idea. We know that 4 cubed is 64, and we know that 3 cubed is 27. So we have to split up our fraction. I want to keep the negative with the numerator. So remember, I'm taking the cube root of the numerator and the denominator. And then when I simplify this, the cube root of negative 64 is going to give me negative 4. The cube root of 27 will be 3. So our answer is negative 4/3. And then for number 7, you're taking the 4th root. So this is going to be 5 to the 4th. But this problem is a little bit different because it's a negative 1 times the 4th root of 625. So it's -1 times 5 to the 4th, right? The 4th root. These exponents cancel. So I'm left with -1 times 5, and I get -5. How to express a radical in simplified form. If you look at the perfect squares chart, we're trying to take out the largest perfect square that we can when we find the factors of the number underneath the radical. So in this case, we have to look at our perfect squares chart, and that from here we can tell that there's nothing that equals, that's a perfect square where 24 is the solution. So if you think about the factors of 24, again, we want to use the largest perfect square. So I have 4 and 6. So what's unique about a radical is that you can continue the sign when you are finding the factors. So this will help us get to a final solution. So based on this, we've split up the radical, and now we need to simplify. The only part that we can simplify is going to be the radical 4, or the square root of 4, which is going to equal to 2. And then because the square root of 6 is a decimal, we're just going to bring it down. And so our answer is going to be 2 square root of 6. You can also do this in the calculator. I want to say no decimals are allowed in these answers. So that's why we're looking for radical form. So if we look at number 9, we have the two factors of 25 and 3. 25 is a perfect square. I know I can place my radical over each number. So then I've split up the radical, and I'm going to simplify. The square root of 25 is 5. And then the square root of 3 is not a whole number, so it's going to give me a decimal, so we just write it right next to each other. I have 5 square root of 3. Number 10 shows us a negative square root of 12. So this is like a -1 being multiplied by the square root of 12. We're still going to find the factors that go into 12, one of them being a perfect square. So I know it's going to be 4 and 3. So we've split up the radical. Now we're going to simplify. -1 times 2 times radical 3. We cannot find the square root of radical 3 because it'll give us a decimal, and we don't want decimals in our solution. So our final answer is -2 radical 3. Number 11 is going to be a -1 being multiplied by the square root of 125. And then you're going to factor out the largest perfect square out of 125. So it's going to be, it's going to be 25. So I'm going to say radical 25 times radical 5. And then I want to simplify. -1 times 5 times radical 5. So your answer is -5 radical 5. And then the last one is going to be 108. So then you're looking for the factors of 108. And that's going to be 36 and 3. Again, you can use like your factor chart to do this. So the square root of 36 is going to be 6. We're bringing down the square root of 3. So our solution is going to be 6 radical 3.